Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. A new guest is in the hot seat today as Dr. Brad cracks on with some work. Thomas Crow, thanks for beaming in.
Thanks for having me.
Great to have you on board. Let's get the headlines in this, the 44th week of 2021. Crew 3 launch delay, a minor medical issue puts plans on hold until Saturday. We now know the depth of the Great Red Spot on Jupiter. And a massive solar flare erupts from the sun.
This is Trekzone's Talkin Science.
And don't forget, Trekzone membership available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Thomas is on Twitter too, @SciCrow. Mate, welcome to Talkin Science. You're a science writer for Perth's SciTech, which is WA's version of Questacon. Tell us about that and a little bit more about yourself, mate.
Yeah, so Particle Science News is a website that basically covers all of the recent science stories, specifically looking at Western Australian scientists, what they're doing, but also with a broader scope for Australia generally. Because I think it's great that we can highlight those sort of stories. I think a lot of science news comes from the US and other places like that, but Australia actually has a really large scientific contribution to the international stage. So it's always good fun learning about new science topics, and the people, Western Australian scientists are always lovely. They always take time to have a chat. So it's been fun, yeah.
One of the things I love doing here on Talking Science is obviously catching up with Australia broadly, scientists from across our great country, WA in particular being the home state. It's always great to check back in with there and see what's happening. We do have a story coming up today. It is great that you're here, Tom. Thanks again for beaming in. First up in our headlines, one from your patch of the world, as I was saying, Binar 1 has successfully sent back its first message after being launched from the International Space Station.
I'm at Curtin at the moment, and everything's Binar 1 here. We have big pictures up, posters everywhere. Everyone's talking about it. So Binar 1's just it's a 6-unit CubeSat, which I have it's not much bigger than this chemistry book here. Shout out to everyone who had to do Blackman et al. In uni. So it's actually very small, which is the advantage of it, because one of the primary issues with any kind of launch is the price of, the mass of what you're doing. It can go up for like thousands of dollars per kilo. And so what they're doing is actually, it's part of a larger project to look at resources on the moon, looking at minerals and water availability. And I think that really tracks well with NASA's kind of larger overarching mission to set up a moon base within, I think it's the next decade. I'd have to double check that. But it shows, it's kind of unusual that we would be, as Australians, looking at doing resource mapping in one sense, but in the other sense, we have a really close partnership with NASA. And we've spent a lot of time, even back to the first moon launch, we've had a really close partnership. So I think that kind of demonstrates the value that Australian science is having in, something that's well beyond any kind of immediate benefit to Australia. It's kind of a step forward for humanity, and we're part of that process, which I think is really cool, and just the fact that you're able to get the tools onto these tiny little CubeSats is amazing to me. That they're able to pack. They really have to pack them in there, I suppose, but they managed to do it, and so yeah, it's been great. I think everyone's kind of following it really excitedly.
Well, the Breakthrough Listen project's strange signal picked up from Proxima Centauri last year isn't aliens after all, unfortunately.
Yes, unfortunately not. People are very quick to jump on the alien bandwagon. When it comes to any kind of foreign signal that we get from space, and I think in one way, that's nice. I think it shows that there's a lot of curiosity out there for what's in space, and I think a lot of people are passionate. And I think there's kind of this yearning to connect with other species to like find that we're not alone in the universe. But in this case, it was not aliens. It was Earth based, basically. It
Yeah,
was
man.
somebody on a radio, or somebody on the phone, or something like that happening. And so these instruments, because we are talking about finding signals from a very long way away. Like it would take, I think I calculated it on the back of an envelope once, it would take 17 times human history, the span of human history, to get to Proxima Centauri if you were on like the fastest rocket ship you could get going. So a while, basically. And we're so taking these signals is very delicate, because they've been redshifted for, I mean, Proxima Centauri, it's not so far away that you're looking at significant redshift or anything, but they're very faint signals over a very long time. And the real issue, and it's one we're coming up more and more against, is that radio signals from Earth are a constant hazard to any kind of surveying of space, basically. So that's something, sadly not aliens, and also it kind of speaks to what we're going to have to do in the future as radio signals become more and more, like we have mega constellations of satellites coming up, and we have Wi-Fi everywhere. This is going to be an ongoing problem, and it's going to worsen over time. So I think we need to look at how we're going to mitigate that.
Absolutely. Well, into our stories of the week, Tom, and SpaceX's next crewed mission to the space station has been delayed due to a minor medical issue. And NASA won't say what that is or who is affected, but they have ruled out an emergency and COVID-19 as well.
Yeah, which is great. You definitely don't want COVID-19 on the ISS.
Exactly.
uh,
Yeah.
for a number of reasons. We don't want any kind of weird space flu coming back when the astronauts come back, that's for sure. But I think it's an overabundance of caution, and for good reason. There's histories of illness in space, and it never ends well. Like the really famous example is Wally Schirra, who got a head cold on Apollo 11, and it led to basically a mutiny. NASA was dealing with some very irate astronauts, and so none of the crew ever got to fly again, basically, as punishment for this poor Wally Schirra getting a head cold in space. And part of it as well is that when you get up there, you're dealing with a recycled environment. All the air is getting recycled, obviously. You're dealing with a very clean environment as well, because an underrated fact of how desire viruses and bacteria and fungi and all the really fun stuff we deal with here on Earth is that they're in a dynamic environment where they're constantly competing with each other, and that helps us to a certain extent, because it means that they're spending a lot of energy dealing with each other, so they're less likely to get pathogenic with us. In space, it's like a laboratory breeding ground, basically. They have their human hosts, which is their favorite food source in the world, and they basically get to pig out. There's nothing there to really stop them besides the astronauts' own immune system, and they're constantly being exposed to these pathogens. So whether it's pathogenic in nature or just injury, I would suspect something like a head cold or something, because it was only given a short reschedule. It was originally rescheduled, I think, to October 31 because of weather conditions, and then we've had to move it back again. So I would imagine it's nothing overly serious. If it was, we'd be looking at either a massive reschedule or one of the backup astronauts coming in. So it will be interesting to see if we ever hear back, because I think at the moment, spacefarer is a really highly competitive field, and so people are very fast to mention their successes, but kind of reticent to talk about their issues. So especially like, there's a massive amount of pressure on a company like SpaceX to be successful. They're competing with Amazon in certain spheres and, other, or Blue Horizon, I should say, but other companies to be primary commercial provider for spaceflight in low Earth orbit. And so I think it's just interesting to see the politics and the dynamics happening behind the scenes. We'll see how it goes, but I don't think it's a major issue unless we do get someone sick up there. In which case, maybe we'll have another mutiny. Who knows?
Well, as you say, this is the second delay for Crew 3 with forecast bad weather, nixing the original launch, pushing it to Halloween, got pushed again, as you say. And NASA astronauts Raja Chari, Kayla Barron, Thomas Marshburn, along with Matthias Mura from Europe, are now in a holding pattern, waiting for their 6-month stay on the station to begin, currently rescheduled for Saturday. Hopefully not another delay going to affect them as well, Todd.
Yeah, I mean, imagine being them. You've spent all this time and energy training to be up in space is like the real career highlight for these people. And there's only so many opportunities you get. You really have to prove yourself on the first try, and if anything goes wrong, that basically throws your whole career into a state of paralysis. I haven't heard any comments coming out from them, which I think is partly mediated by, the PR department of SpaceX, but also hopefully just the good grace of the astronauts realizing that it was something beyond their control. So yeah, I mean, I really feel for them, but I do think, it's still going ahead. You can never count a rocket launch before it happens, I think is the conventional wisdom. You never want to count your chickens before they hatch, but it seems like all signs are go, and it's just whatever it is, a cold, somebody slipped on a banana peel, who knows?
Well, next up, we've known for some time that the Great Red Spot on Jupiter is, well, great, but only now do we know how deep it is, Tom.
Yeah, not very deep at all, apparently. I
Hmm.
think it was 500 kilometers down, which is a bit of an anticlimax for, I suppose, that very select group of people in the world that are avidly watching for the Great Red Spot news. But I mean, considering the intensity of the storm, it's famous for being, I think it is as large as planet Earth or something like that. It's a massive storm, larger probably. And, it's a really intense storm, but it doesn't go down very far. I think the real interesting part of this story is how they figured it out, because if you consider this, it's not like they're able to send a satellite down there to check out. They didn't drop an anchor and go, oh, it's this deep. You can't send satellites down into the storm because they have a terrible habit of being destroyed because it's a cataclysmic level storm. So what they did, and I think it's really cool, is they looked at the gravitational disturbances caused by the storm. So this storm is not just a thing happening. It's an event with a specific mass, basically. And so they were able to calculate the density of these clouds in the storm using some mathematics that I, as a lowly science writer, am well and truly beyond. But they were able to calculate the density, and then they compared that to the gravitational disturbances that the storm was causing as a big dense cloud of matter that's accelerating quite quickly. And so then they were able to infer the depth of the Great Red Spot, and it was only 500 kilometers down. I think the important thing to note about this is that it's an opportunity for more research as well, because this is just a cursory. I mean, we've seen it before. There's so much happening in space at the moment, that, and a lot of it's to do with, microwave radio meters, as is in the case with, or spectroscopy or spectronomy. It's one of those ones. But these kind of observational devices that rely on monitoring radio waves and light waves, and we still don't have a real certain guess about, like, we can't send satellites down to a lot of these places yet. So it'll be interesting to see what further observations do. It's been moved. The mission's been extended for another 4 years, and they're going to go over to the moons Io and Europa, and probably dig around there, see what they can find. So yeah, I think it's interesting. A little bit disappointing that it's not like super deep. Just for me, like, I don't know. I kind of was hoping it was going to be like, oh wow, it's going to be really, really deep. But it doesn't matter in any real respect, I think. It is still a massive storm, and it's been going on longer than human history, which you've got to give respect to. So, yeah, we'll have to wait and see.
Yeah, absolutely. And Juno's been orbiting Jupiter since 2016. As you say, mission extension, heading over to the moons soon. There's still plenty to explore. There's a ring system there around Jupiter as well. Plenty of stuff for us to find out, especially given that around 1,000 Earths can fit inside Jupiter alone. Then you've got orbits of the moons as well. There's so much to explore over there.
Yeah, and I think it's a really interesting area. I know a lot of astrobiologists follow Jupiter and its moons quite closely because it's a low possibility, but there are possibilities of signs of amino acid buildings and amino acid molecules rather, and sort of those building blocks of life potentially being there, and what that would mean for any life that evolved on places like Europa, which is one of the places that people look at quite a bit now, and they're like, maybe there could be life there, maybe just a little bit, but it's not a very hospitable environment, especially to humans, but it could be. Stranger things have happened. Well, not many, but
Exactly right. Well, lastly this week, Tom, a massive solar flare has erupted, class X1. Sounds pretty scary.
Yeah, so in this case, it was because of a coven of witches was doing a ritual. No, I mean, solar flares happen now and again, and it is because obviously the sun is such a dynamic, real energetic system. I mean, it has to be. It basically lets us exist, which is important, yep. I think. But it's well timed. I'd say. I think the really cool thing is when we're looking at auroras like this, it's kind of like a really large scale spectroscopy. The oxygen gives off these green and red colors as it's messing with the magnetic fields of the Earth, and nitrogen goes purple. So you can kind of identify what's being stripped of electrons by the solar flare's magnetic ejection. Which is cool. It's kind of like science in action, I guess. You don't need to have a $1 million lab set up to see these molecules, basically.
Yeah.
So I mean, it is large. I think there's always a worry people have with solar flares because we are kind of at the mercy of the sun. I'm a big science fiction fan, and The Wandering Earth by Zhijin Liu is a mainstay of that. Where Earth kind of has to put some big rockets on the back of it because the sun's about to turn into a red giant, and we all know that's kind of the fate of Earth. That one day we will be swallowed by the sun. But I think it's a little premature to worry about this solar flare ending life on Earth. And, boy, will my face be red if any solar flare ever, literally, ever envelops the sun. But I think we're okay.
Well, the video that we just saw was taken by the Solar Dynamics Orbiter, showing off that X-class flare, which are the most powerful types of storms the sun can have. It's not uncommon. It does happen. I think most recently, it happened in the last decade. So, Tom, just for people that might not be aware, what exactly is a solar flare?
A solar flare is, basically an ejection of energy and matter from the sun. Generally comes from, as I was saying, the sun is a big thing. Very scientific term, yeah. And it's also a very powerful magnetic thing. And so when the magnetic lines of the sun get adjusted either through, energy is constantly, it's this big swirling thing of energy. And when this energy causes magnetic lines to get tangled in the sun, or shifts over, basically the magnetic line shift, it can cause this coronal ejection. And you have to consider, like, the sun is a really weird type of explosion. Basically, its mass is so powerful that it's able to basically fuse atoms together and form new molecules. I mean, that's how we get all of the complex molecules that we have, not necessarily from suns like ours, which is, kind of just fusing smaller molecules together. We're not going to get really cool stuff like gold happening or anything like that. But it is this thing that's kind of pulled together by its own weight, and it's constantly yearning to break free because it's so energetic. And so these coronal ejections are just a part of that. It's when the energy builds up so much, basically, that it's able to escape its own gravitational pull. And then, in more intense suns, we get issues. For instance, I guess you couldn't classify it as a sun, but a neutron star, maybe. They're really famous, and we've seen a lot of things in the news lately in the last couple of years about signals from. There's a popular theory that the fast radio bursts that we were just absolutely stunned by when they came through were caused by neutrino stars and their ejections. So the power of these ejections is determined by the energy of the sun and the mass of the sun, not necessarily the size, because big suns can be low in mass, and little suns can be dense enough to warp the gravitational space-time around them and, mess up all kinds of weird things. They are basically just the sun throwing up.
That's
To put it
a
in
fair
layman's
analogy.
terms.
That's very good.
Yeah.
And thankfully, more often than not, the end result of all those charged particles escaping the sun is a spectacular light show in Earth's polar regions caused by those charged particles interacting with our upper atmosphere, giving us the aurora borealis in Skinner's kitchen at this time of
Yeah.
year, and also aurora australis for us down in the southern hemisphere as well.
Yeah, and I mean, it's lovely. If a devastating amount of charged particles being ejected from a titanic mass, which could at any moment kill us, gives you a nice light show. Cherish it. Cherish every day, people. But especially the ones where you get nice light shows. And I'm not sure if we'll be able to see it here. I guess it's past already, but I think that they always do these Antarctic and Arctic light shows, and I think, like, that's one of my dreams, just go out and see these things, because it seems like a wonderful thing to do. And I think it's also another one of those things where it's getting rarer for us to have those opportunities because of things like light pollution and the density of our societies is coming so that we see less celestial phenomena.
Just before we go, Tom, a look ahead to when I continue talking science. Dr. Phil Bland will beam in to discuss Binar 1's successful phone home, as we talked about at the start of the show. That Binar 1 satellite is part of the Binar space program, which has been supported by the WA state government, who invested $500,000 to facilitate joint operations with the Fugro Spark facility. And is also supported by the Australian Remote Operations for Space and Earth Consortium. The program is set to launch several more satellites before culminating with the Binar Prospector mission, which will orbit and gather data from the moon. The success of Binar 1 will pave the way for future Western Australian missions. And while I thought the name was a nod to the Star Trek species, it's actually named for the Noongar word for Fireball. Members will have first play access to that interview later this week, so sign up with the join button below this video on YouTube or go to the Trek.zone/support to get access for less than a cup of coffee a month. Tom, it's great to pick apart the stories of the week with you. Thanks again for beaming in. We'll catch you in the future.
Thank you for having me.